Hi everyone, and welcome to this video about compound percentages. If you enjoyed this video, please remember to like and subscribe. And if you have any questions about the content of this video or any other question about maths, please leave it in the comment section down below and I'll get round to answering you. To understand compound percentages, we first need to understand the idea of a multiplying factor. And if you don't know what this is, please check out the other video linked in the description, which I explain this concept in. First, let's look at the case where I save some money with a certain interest rate for 1 year. So using the idea of the multiplying factor, I know that in order to keep my original sum of money and to add on the percentage increase, I need to multiply 500 by 1.08. By the end of the first year, I'll end up with £540. So let's say I go back and change the question, and instead of 1 year, I want 2 years. So after I've saved the money for 1 year, in my bank account, I'll have £540. So going into the second year, the bank is going to calculate interest based off that money. So my second calculation is going to be 540 times 1.08, which is £583.20. Okay, let's go back and change the question again. Let's say instead of 2 years, I wanted to save the money for 3 years. So at the end of that second year, the bank would base its calculations in how much money was left after 2 years. So going into my third year, this is the calculation in order to work out what my money would increase to be, and that would be £629.86. So we can see that each year we've taken our answer and multiplied it again by the multiplying factor. So instead of writing it out into 3 steps like this, I can simplify the process. I can take 500, multiply it by 1.08, and take that answer and multiply it by another 1.08, and finally, in that third year, multiply by one final 1.08. And here, if I remove the brackets, you can see that I'm just multiplying by 1.08 3 times. Multiplying by the same number 3 times is just the equivalent of cubing a number. So I can write this in the form 500 times 1.08 to the power of 3. So we've taken a complicated compound interest question and we've simplified it to this one expression here. Let's just break down what the numbers in this final expression mean. 500 is my initial amount of money, or the original value. 1.08 is my multiplying factor that preserves both the original amount, because of the 1 in front, and adds on a percentage increase with the 0.08. And the 3 is how many times I want to apply that percentage increase. Now, in this case, it's like a rolling interest rate. The interest is calculated based off how much was left from the first year, in the second year, and in the third year was calculated by how much was left in the second year. So in a case like this, I can multiply it by 1.08 to the power of 3. Let's look at this question here. I start off with a car worth £5,000, and every single year I own the car, it loses 10% of its value. So after 4 years' time, what will the car be worth? Let's begin by calculating after 1 year how much the car would be worth. So I take 5,000, and remembering that for a percentage decrease, I multiply by 1 minus my percentage over 100 to get my multiplying factor. So that's 5,000 times by 0.9, which is £4,500. In the second year, I take 4,500, do the same multiplication, and so on and so on. But I now know that I can simplify this process, because I can take my original value of 5,000, multiply by my multiplying factor. I know that I'm going to be multiplying by this factor 4 times, so I can just raise it to the power of 4. Our final answer is 3,280.50. Looking at this example together then, we start off with something worth 50,000. The value increases, so we've got a percentage increase, by 2% each year, and we've been given the start time of 2009, and the end time of 2017. So how many years has this company had to increase in value? Well, we're going to do 2017 minus 2009, which is 8 years. We know that our multiplying factor is going to be 1 plus 0.2, so we can take the original value of the company times by our multiplying factor, raise that to the power of 8, and that will be the final value for the company, which works out to be £58,600. In some questions, we might be expected to find other values, not just the final value. For example, in this question, we're asked to find the actual percentage that we're increasing by. In a case like this, we can set our unknown value as an unknown variable. This question has already done that for us. It's set it as x. We're going to go through the question just like we would, and we're going to set up an equation. Let's start by working out our multiplying factor, remembering that we must do 1 plus our percentage over 100 for a percentage increase. Let's keep that in a set of brackets. The starting value was 250,000, times that by our multiplying factor, which in this case is raised to the power of 6, because that's how many years the company has had to increase in value, and that will be the final value, which is 325,000. So now we're going to process this equation by doing the same thing to both sides, dividing both sides by 250,000. Then we can do the 6th root of both sides. We can subtract 1 from both sides now, and finally multiply both sides by 100. Putting this right-hand side into the calculator, we get our percentage, correct two significant figures, of 4.5%. Let's look at one final example together. So here I'm asked if I invest £500,000 at 5% compound interest per year, how long will it take to double my money? So the thing that I don't know here is how long I'm going to invest my money for. So we can write the rest of the expression, leaving that number of years to be the unknown variable. So I'm going to start off with my initial value, which is 500,000, times that by my multiplying factor, which in this case is 1.05. However, I don't know how many years. I'm going to use n as that unknown variable. And on the other side, I'm going to have my final value, which is double my initial value, so that's 1 million. Let's divide both sides by 500,000. And now for this step, we could either use logarithms, but it's highly unlikely. We've studied that at GCSE. So in this case, we need to do trial and error. We're going to try different values for n, and we're going to find the first value in which our answer on the left-hand side is greater than 2. So if we try 14 in this case, we'll find the answer is 1.9799. So that's not quite 2 yet. Let's try 15. We find that the answer is 2.0789. So the first value of n for which our answer is greater than 2 is on this line here. So n must equal 15. So how long will it take to double my money? Well, 15 years. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.